Hi, this is Randall Schwartz, host of Floss Weekly. This week, Dan Lynch joins me once again. We're going to talk about the Go programming language from Google. It's like a systems programming language like C++, but better because it's faster and easier to use. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Dan Lynch. Episode 284, recorded February 20th, 2014, the Go language. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the followers, the movers? The followers? That's what he says. The movers, the shakers, the leaders, the new projects, the projects you might not have heard of, the projects you may be using every day and not be aware of it. Joining me today is none other than Dan Lynch. Welcome back to the show.
Hey, it's good to be back. Yeah, it's been a long time.
We were just figuring out before the show that we actually haven't been on the show together, I think, in almost half a year. Although you've been on the show how many times since the land? Probably like a half dozen.
Oh, God, no, I don't know the number off the top of my head, but it's probably 10 or so. Like
yeah, right, because you guys had to fill in while I was on all those wonderful cruises. So welcome back. Good to talk to you again. And you've been busy, I guess. You've been working on, FOSDEM and Moo Camp? No,
yeah. Unfortunately, I didn't get to FOSDEM this year, but no, I wish I had. But no, I've been doing lots of stuff. I'm working on a big web project at the moment for a national organization. So we're fingers crossed it's all going to go well. It really is. We believe it's all going to go well. So it's going to be good.
And you're in your usual Liverpool location, I take it?
I am, yes. I mean, for anybody who knows the UK, or knows Liverpool, in fact, I'm actually not far from Lime Street Station, which is the big train station in Liverpool. I'm less than a few hundred yards from Lime Street right now.
And I am also in the location I've been using recently, my new client, ZipRecruiter, who provides wonderful bandwidth for me, so I can actually sit here and not have Skype dropouts. Well, the show's not about us. It's Santa Monica, California, by the way, so just to fill that in. The show's not about us. The show is about our guests. We have a really special guest today. I keep saying that every time because we really do have a lot of really special guests. We have Frances Campoy. I hope I pronounced that right. He is speaking to us about the Go language. The Go language is a language from Google, open sourced, had its first release, I think, a couple of years ago, and has been updated actually very recently. We'll talk to him a little bit about that. And as best I can tell, the language came about because Google wanted a nice, easy language to do high-performance applications, mostly server-side, apparently. It doesn't run in the browser, so server-side stuff. And they got tired of writing stuff in C and C++. They kind of wanted some modern features in there, so they created their own language. So that's my observation of it. I tried to do about an hour's worth of scanning before the show, and I'm sorry I don't know much more about it than that. But we do have an expert on, so we'll bring them on in a moment. Dan, what have you seen about so far in Go?
I've got to be honest, I've only quickly had a look at it, but I hear a lot about it, and I know there's a lot of interesting people involved. I'm interested to see how it fits in with the rest of their strategy. We were talking about Dart before, and I know that's a JavaScript thing. So it'd be interesting to see how it fits into Google's kind of wider strategy, I would say.
Very cool. Well, rather than us chatting about it and wondering idly, why don't we go ahead and bring on our guest, Campoy Flores. Welcome to the show. Oh, I got that backwards, darn it. Frances Campoy. Sorry, it's morning for me. Welcome to the show.
Thank you.
Yes, and where are you speaking to us from?
So I'm here in Mountain View, the Google headquarters, where it's 8:55 a.m., pretty early.
Early for engineers, come on. It's not. I've been up since 5, so come on, guys. It's not that early. If I can manage to do that, then you guys can do that too. But well, thank you for appearing on the show. And the Googleplex, I've actually been there. Used to be the old Silicon Graphics headquarters.
Yeah, that's it.
Yeah, in fact, it was really weird because I did a Google Tech Talk there, and they took me right to the very same room I used to teach my Perl classes at Silicon Graphics, so that was pretty strange. So I sort of gave the 30,000-foot view of Go just a moment ago. Why don't you start and sort of fill us in, like how did Go get started, and what problem was it created to solve? No, what problem was it created to solve? There we go. That is actually English. Okay.
So yeah, basically what you were saying was totally right. It was created Actually, it started as a 20% project by some engineers, so Rob Pike, Ken Thompson, and Robert Grismer. And what they were trying to do was to create a new language to solve the problems that they were trying to solve already. So writing big servers where using concurrency would be easy, and also it should be easy. It should be very easy to read, because one of the problems of C++ is that understanding what the code that does exactly all the time is not that easy. And here at Google, at least, we spend way more time reading than writing code. So that was one of the premises of Go. It has to be really, really readable.
Well, there were a lot of languages in that space already, though, and I mean, like Erlang for concurrency, things like that. Although I wouldn't say Erlang is readable at all, but I'm going to get hate mail now. But so why start another language when there's already a lot of things sort of in that space, or was it? Yeah, I'll stop right there.
So there were indeed there were other languages that provided some parts of what they were looking for. But actually what Go does is pretty much gathering different features from other languages. So as you were saying, Erlang has a very good concurrency model. And actually the one that Go provides is very, very similar to it. But Erlang at the same time, its syntax is far from readable unless you're very used to it. So Go, what it tries really start from C and add two things mainly. One is concurrency. The other one is interfaces. So we can talk a little bit more about it later. But basically what it does is trying to bring C to be a modern language. Also adding garbage collection, because memory management in C and C++ is one of the biggest pains. It's one of the easiest ways to get to some really weird bugs like memory corruption or memory leaks.
Yeah, I know. I remember in the little I've studied of C++ always talked about if you implement one of the three of your own allocator or your own destructor or something, you had to implement all three all the time, you'd always end up with a memory leak. So I thought,
yeah, otherwise you end up only freeing part of the object, not the other part. Yeah, these kind of things. That won't happen in Go, luckily.
Okay, because I remember that sounded like, why would the language force me to do three different things when I want to do any one of them? That's just crazy.
Yeah, I think that one of the reasons that Go was created was probably I don't know if you've seen the last version of the C++ specification, but that was a very good reason to create a language. When you need a huge book to understand a language, that starts to be a problem. And Go, the whole specification is actually pretty readable. I read it myself, and it's like, I think that if you printed it, could be something around maybe 20 pages, and you have the whole language there.
Wow. So it sounds like it's probably one of these languages that's sort of easy to sort of get the big picture of, but then you've got, of course, all the subtleties that eventually you learn the nuances of it. So how long does it take for somebody to be productive in Go when they first start playing with it then?
There's one tool called the Interactive Tour. So it's accessible on tour.golang.org that takes you through the basic features of the language, including interfaces and concurrency. And by the end of the tour, you end up implementing a concurrent web crawler. And that takes around 4 hours, the whole thing.
Wow.
So after 4 hours, you're able to pretty much understand the whole language. Then getting used to it and actually writing code, maybe like 1 week, something like that, writing code, you should be able to understand the whole language already. And then the important thing about Go is actually it's not only a language, it's also a little bit of a philosophy, where we actually have what we consider to be idiomatic in Go, which basically is you have to be sure that you're not repeating information too often. We try to avoid long names, so especially if you're coming from Java or basically Java, where you end up having identifiers for variables that are crazy long, and you're okay with that because if you're using Eclipse, then you have autocompletion. In Go, we try to avoid that, just because it's just you end up having code that it's shorter and in general more elegant. So that takes more like probably 2-3 months. And I mean the project started in 2007, but the Go 1.0 version, the first stable version, was only 2 years ago in March. So there's not really too much to learn. It's a pretty new language, and basically everything that is in the language is the community, and we're still evolving some of the patterns, and people find out new ways of using Go, which is always really nice. But basically, what is good about the language is that the features that we have, they're very orthogonal, meaning that once you understand one feature, then you go to learn the second one, and those two interact in a predictable way. You won't have weird instances or weird cases where, for instance, I could think about when you're using C++ and you use templates, all of a sudden there's a lot of things, like even scoping of variables that changes and these kind of things. In Go, in general, it's really difficult to find a surprising case. We know 1 or 2 cases that with the power of retrospection, now we know that we should have done it a little bit different. But it's just like some little details of the language that we might change someday in Go 2.0. But in general, the language is actually very, very, very simple to start learning. And for me, even more important, it's very easy to read the code. So one of the things that people normally do to really get this idea of what is idiomatic is actually reading the standard library. The standard library is totally available. The project is an open source project, of course. So you can just read the actual standard library that has been written by the creators of the Go language, and also the committers of the rest of the community. It's actually very simple to read.
We actually have a question from the chat room, from Akko in the chat room. Does the readability affect performance? Are you doing any trade-offs there to make it more readable, therefore kills more performance? So
one of the premises of Go is that it has to be very efficient. We use it at Google, and we use it in very performance critical places. We use it, for instance, one of the pretty much the metadata database for YouTube is an open source project called Vitesse, and it's fully written in Go. So it's important that it has to be really fast. It's slightly slower than C++ now, but we are actually working on the next version of Go. It's Go 1.3 that will be released in June. Basically, what we're doing is rewriting some of the parts of the runtime so the language will be actually faster. So we're not trying to add more into the libraries or more into the language itself. We're just trying to make it faster and faster. So right now it's probably slightly slower than C or C++, but this shouldn't be the case for a very long time.
So is Go a command line language? Does it have network interfaces? Does it talk well to databases? Where does it sort of fit in the ecosystem? So Go is actually a very good position to use any kind of networking. The net package in the standard library is very, very good. I consider it one of the best ones that I've ever seen in any language. And it allows you to write very simple code, especially when you're using, very, very often when you're doing networking, one of the things that you have to do is listen to things and react to them. In Go, you can actually do that concurrently. So you have different Go routines, or you can think about Go routines as very light threads. So you have different threads that are reacting to different events. And the code for that is actually very simple. You don't need to use callbacks that end up having some kind of spaghetti code, but it's callback spaghetti code. In Go, pretty much all the code that you're going to write is going to look very sequential. And at some points, you're going to say, actually, this part, I want you to execute it concurrently. So for network, it works really well. And also, of course, for HTTP servers. The HTTP package also is very good, so there's a lot of people using it. The download page for Google, so dl.google.com, where you can download Google Earth or any other big binary. It's also written fully in Go. It used to be written in C++,
It was migrated by, among others, by Brad Fitzpatrick to Go. And during that progress, we improved a lot the HTTP package. So those are like networking and HTTP works really well. Also, encoding and decoding, since we have a pretty powerful Reflect package, encoding and decoding for JSON and HTML, XML is really easy to implement. So that allows you to pretty much create easily web servers that provide HTTP REST APIs or these kind of things. It's actually something that is really easy to do, and lots of people are actually using Go for that.
When you're talking about downloads going through this Go program, are you actually sending the entire content of Google Earth through the Go program, so it's going in and out of there, or using something like send file that you can actually point back to the file system?
So I don't know the exact details of the implementation. There's a talk somewhere. So the project is called Glory. It used to be called Lorry, like a truck, but now it's called Glory with a GB for Go. And I don't know the exact details, but basically, if I'm not wrong, there's actually there's no disk anymore. Instead, there's Memcache that actually stores all the files, and then Go is actually surfing directly from there.
Well, that's pretty significant then. And what about other things like database access?
So for database access, the standard library doesn't provide a driver itself. Instead, what we provide is an interface and a set of tests. So then afterwards, there's some people that have implemented all the drivers. So we have most of the drivers that you can need already there. So I can think, for instance, about MongoDB. Actually, the driver for MongoDB, it's the MongoDB itself. They're using Go, and they also provided a driver for Go. I think that there's also MySQL. I haven't used many of those because in my day-to-day job, normally I do stuff on the cloud, so I end up using data stores and these kind of things rather than databases. But the database that is storing all the metadata for YouTube, it's actually a MySQL database with a Go layer on top to make MySQL scale.
Wow, that's awesome. One other thing immediately comes to mind, and we'll let Dan take a few whacks at questions here. Is there anything equivalent of Perl's CPAN? And if you're not familiar with that, I'll explain it.
I don't know exactly what that is.
Oh, so that's the user community can upload packages that other people can use.
Oh, so not exactly. What we're using is we allow, so when you write Go code, the way you import packages is actually through what we call an import path. That is actually a URL. So when you import a URL, you can say you want to import, I don't know, one package that I created. It's called to do. So I'm gonna write my code, import github.com/compose/to-do, and that's just gonna work. The Go tool then, when you do go get or go install, it's gonna retrieve all the code and all the dependencies for it.
But does that mean then that you have to have that net connection in order to run that code, or does it eventually cache it locally?
It's cached locally. So when you do go get, it will get the code, and once it's already in your machine, it will get it only if there's a new version. And also, one of the problems with that is that what happens if you want to actually have a frozen version of it and don't depend on eventual changes that the third-party library could do. What there's a lot of people doing, it's create a third-party directory in their own repository where they actually have a frozen copy of the libraries that they're using, and then they update it when they think it's needed.
I was just reading on the through some of the Go information there on the website about linking to C or C++ programs, and it talks about there's two different implementations of the compiler. Can you explain that a little bit for us?
So there's two different. There's actually maybe more than two implementations of the compiler. The Go language is actually just a specification. The compiler is not part of it, but we provide two different compilers. We provide just a Go compiler. I think it's just called GC. And this compiler, so Go compiler, this compiler is written in C right now. It was written by, if I'm not wrong, by Ken Thompson, basically, and Russ Cox. And at the beginning, now it's being maintained by a lot of the other people. And it was created as the, let's say, to demonstrate that the language was possible. But it only targets some specific platforms. Then to target more platforms, what we did was create GCC Go. So GCC Go is actually the front end for GCC, so for Go. So it allows you to compile, to cross-compile to other platforms, which means that also we get to get some optimizations that GCC does. We get them for free. And actually now we're working in translating the GC compiler that it's fully running in Go. We're working on rewriting it in Go, except that we're not gonna just rewrite it. Actually, we're gonna write a tool that's gonna translate the C code that we have into Go, and then we're gonna edit that Go code to get idiomatic Go code. So normally by June, depending how it goes, I'm really not sure how it's going right now, so I cannot really promise that it's going to be done really soon. But basically, soon we'll have a Go compiler reading Go.
Excellent. That sounds very, very cool. And you, obviously, Google are using Go a lot from the sounds of it. And I don't know if you'd be able to answer this, but I'm going to ask it anyway. Do you know what adoption's like outside of Google? What are other people doing with it? Do you have quite a good buy-in from the community?
There's actually one of the things that I do regularly is check Google Trends and look for Golang. And the curve is always very nice to watch. And there's a lot of people outside that are using Go. There's actually one of my favorite companies that are using Go is SoundCloud. They're using Go. So I don't know if you heard about SoundCloud, but basically it's like I like to call it the Twitter for musicians. And there's also Heroku. They're not only providing cloud services for Go, but also part of their infrastructure is running Go. MongoDB is also part of it running Go. There's a service orchestrator called Juju that is also being running Go. And what else? I always forget some of them. There's actually a lot of companies, and the cool thing is that most of them, even if Go was created with the basic idea of creating a substitute for C and C++, actually most of the companies that are adopting Go are companies that were using before dynamic languages such as Python or Ruby, and they're migrating to Go because they're pretty familiar with the syntax. It's a pretty simple syntax. They really love the fact that there's garbage collection, so they don't have to take care of freeing memory. But it's way faster than most of the dynamic languages. Well, actually, probably than all the dynamic languages that you could find. So it's actually a lot of people like SoundCloud. I think that they were written, everything was written in Python, and at some point they identified one of the servers that was a bottleneck, and they decided just to rewrite it in Go, and they were so happy with it that actually they wrote a blog post about it and the whole experience.
Excellent. I mean, you mentioned that. I thought you may lead into it. In the information you sent us, you were talking about music generation with Go, and as a musician myself, I thought, oh, hello, my ears kind of pricked up. So people are using it for music generation, like synthesizers and so on?
So I created this talk, singing gophers. So the gopher, by the way, is the most important program. And so my idea was create some music with Go. And what I did was choosing CGo, which is a tool that allows you to embed C libraries in Go and provide a Go API for those libraries. I created a little demo with a little bit of a DJing, and just it could actually parse some notes, and it was more like playing with MIDI rather than anything. But there's also, so I'm a classical musician, I play piano, but there's also Andrew Duran, and he's actually more of a modern musician, and instead of notes, he likes to think about sound just waves. And he's also working on creating a synthesizer. And what he's doing is actually really cool too. He's way more low level, but it's also all written in Go. So far it's mostly playing with it, but actually it worked really well because the concurrency features of Go allows you to play really easy with the idea of having different Go routines as different instruments. So you end up having lots of fun, basically.
It sounds excellent. I love the idea of singing gophers, I must say. I was just thinking about, you talking about synthesizers and so on. What about things like embedding Go programs onto devices, like maybe in the future some kind of keyboard or synthesizer and stuff? Is that ever been thought of in the whole process, or is it more a server-side thing for now?
So Go hasn't been designed to be something that is embedded, but we do cross-compile. So there's people that have used Go on Raspberry Pi successfully, and it actually works. Also, you can cross-compile it to ARM, so any processor like Android, you can use Go on top of it. Even if accessing the SDK for Android right now, it's not well supported. It runs perfectly on Android, and Brad Fitzpatrick created this project called Candly Store. So it's pretty much like somewhere where you can store all your information in a very easy way. And they have an Android client. The Android client is actually written fully in Go, except for a little layer of Java to make it work with SDK.
Excellent. And does it always have to be compiled, or can I use it? Is there any kind of interpreter or something I can use just to try things out as I'm going along?
So there's not an interpreter right now, but actually compiling it is really fast. So there's something that we're doing. So there's the tour that you can actually write some Go code on the web. It's compiled and executed. And we're doing that using Knuckle, so native client. So that allows us to have Go running instead of a sandbox. Using that is actually very easy to create a basic interpreter. So basically, that's what the tour or the playground do. So play.golang.org. When you write that code, it's actually sent to some server where it compiles and runs and sends it back. And it's actually compiling. It's generally faster than starting any interpreter that you could imagine. So basically, there's no much interest of actually having an interpreter for Go right now.
Okay, so there's no need to go and get a coffee while you wait for your code to compile and come back. Okay.
Yeah, the XKCD of it's compiling. Yeah, it doesn't work anymore.
Yeah, exactly. Okay, so what about things like development tools, so IDEs, and how you go through the debugging process and so on? Is there much? What's the support like for that kind of stuff?
So personally, I'm using Text Sublime too, and I'm really happy with it. There's a plugin called Go Sublime, and I'm really happy with it. It allows you to do code completion and syntax highlighting. And personally, I'm not a kind of person that enjoys using Eclipse. I prefer to write my code myself. So I'm really happy with that. There's also people that have been working on higher level plugins, higher level IDEs. So there's, if I'm not wrong, it's called Idea Go or Go Idea. So basically, it's based on on Idea and just a plugin on top. But they're working really hard right now because we created a new type package. And this new types package allows you to use, so there's one of the tools called Go Oracle that allows you to do more introspection on your code, find where your variable is being used and these kind of things. So actually there's a lot of people improving the support for IDEs right now.
Excellent. And is it easy for me? So is it easy for me to kind of step through the code and all that and do my usual kind of tracing and all the rest of it? What would you use for that? Do you just compile it and then get it back and see what happens, or?
Yeah, normally what you do is just you compile it, and actually with Go Sublime, what I have, it's just like when I do command space, it just compiles it and runs it and shows me the result directly. There's a lot of different ways of doing this, of course, but basically it's if you want to use debuggers, so we have support for GDB. The support is not great right now, especially support for GDB on Mac. It's actually a little bit clunky, so we know that and we're working on it and we're improving it. So one of the solutions might be actually creating a new debugger for Go from scratch. This is something that we may do, but we're still deciding it.
Okay. And what about things like unit tests? I mean, obviously that's an important part of any development process. Is it easy for me to just set up unit tests and things as I go along?
Yes, actually, the testing, all the testing framework is part of the standard library. So we have a package called testing, and it allows you to run unit tests, of course. That's pretty simple to do. And actually, there's a blog post about it on the blog, on the Go blog, about how to write unit tests. It's really easy, really simple to do. And actually, the good thing is that it's so easy that you end up doing it for real. And then also the same testing package allows you also to do, what's the name? I forgot, performance testing. So you can use benchmarks. That's also integrated into the language. So that's really easy. And you can very easily say, okay, for instance, if my test is 10% lower than it should be, I'm going to just fail. There's also finally some examples. And that's actually something that I really like. In Go, we have GoDoc, which is a tool that extracts documentation out of the code. So similar to JavaDoc or PyDoc, but there's no special syntax, just text. And part of the documentation that it generates, it's actually examples that at the same time they're tests. So actually on the examples, you write the example on how to use your API, and you also write in a comment the expected output. This means that actually that example is not only going to be part of the documentation, but also every time that you run your test suite, it's going to be checked out. So if your documentation is out of date, you would actually get an error.
Oh, excellent. So, I mean, documentation is one thing that I know a lot of, I say this a lot on this show, but I kind of feel the pain personally. A lot of developers don't like documentation. I mean, writing documentation. So that's like an incentive to get them to write the documentation, because they're also getting the testing side of it as well.
Yeah,
that's very clever.
Actually,
I like that.
I've already had the case where my documentation was not up to date, and I realized because I run Go test and it fails. It's like, oh yeah, my documentation. So it actually enforces you a little bit the fact that your documentation should be up to date. Also, the fact that the syntax for the comments is just plain text. It also allows you to just write your documentation as you feel. It's very, very simple, and you don't have to be thinking about, oh, wait, what's the syntax for this parameter on these types, things like this. Just you have to write comments right before the type that you're, the identifier that you're documenting, and that's it.
Mm-hmm. Excellent. And we've talked a lot about the kind of technical side of things, but I'm going to put that aside for a second while we talk about the exciting world of licensing and other things, which I know developers also love. But I noticed it's under a BSD license. Is there any particular I mean, I don't know if you had any influence on that decision, but do you know if there's any particular reason why that was chosen? Because I was under the impression that Apache 2 was very popular within Google for projects, be they 20% projects or normal ones.
So actually, I don't really know much about why BSD was chosen. I think that it allowed exactly what we needed at that time. I think that one of the responsibles for choosing this was probably Andrew Duran. He was managing the Go community at that point. But that's a very good question. But unluckily, I'm not really sure I could answer that.
That's okay. Okay, then. So what about things like, I mean, obviously this is a Google project originally, and we talked about other people using it. There's buy-in from other places. What about things like governance? Does Google kind of lay down the law and say this is what's happening with Go, or can other people, is there any kind of board or structure there that people could, get onto or join?
Really a board. I mean, we still have a little bit of the control of the Go community, but basically, it's more like a moral control than anything else. We are only around, in the Go team, I think that we're between 20 people, something like that, inside of Google. And we have more than, I think by now it should be something like 300 contributors. So there's, even if we wanted to control the community, it could be really difficult. So basically, we have some, we try to control a little bit the process, the distribution process, and actually the release process. But what we include in each release is actually very, very influenced by what the community is asking or providing.
And then 300 is a great number of contributors. That's actually what I was going to ask. One of the questions I was going to ask, you've preempted that, was how many commits and things do you get from people outside the company? So how do you manage all that? Are you just using something like Git, or how do people get involved if they want to kind of come along and say, I've got a great idea for Go?
So there's the first thing that if someone has a great idea for Go, the first thing that they should do is send an email to the community proposing that idea. One of the worst things that happens is when you write all the code that you think is a great idea and then you provide it and someone says, actually, it's not such a good idea. So we try to always get people to send first their ideas and a design document of what they're planning to do. And then we have a very detailed contribution guide on the Golang.org page. But basically, you're able to create your. So we use code.google.com. So and with Mercurial, and on top of that, we have a little script that allows you to use Readville for code reviews. And once you get the go by some owner of the code that you're trying to modify, then you're good and you just submit it. But basically, the most important part is you should first join the community and express your opinion about what you want to change. There's a lot of people proposing changes to the language, and the problem is that very often there's people that are very, very new to the language, and what they're trying to do is just adapt the language to what they know already. So trying to make their language more like Python or more like Java or more like any other language. So in Go, what we try to do is make sure that if there's something that we can improve and it makes sense, we will improve it, but we don't want to bloat the language with too many features. We want to keep the language simple and performant.
Well, we don't have a lot of time left, unfortunately, because I really have a whole bunch of questions I really want to keep asking. But one of the things I'm sort of curious about is how portable is this? Can I run this on lots and lots of different platforms?
So you can run it on all the big platforms. So you can run it on Windows. You can run it on any kind of Linux. You can run it on Mac too. You can run it on ARM. I've seen people running it on Raspberry Pi too. So on FOSDEM this year at FOSDEM actually was a pretty fun event because we had one Go dev room. It was all day long, was really full, and there was someone explaining how they ported Go to NetBSD.
Oh, cool! And what if you had to list like the three most important features that distinguish Go from most other languages? What would you say they are?
So for me, the most important one is it's readable. So it's very, very readable and simple to read. So you can get anyone's code and read it. Also for that, there's this tool called GoFont, which is a free printer for Go that we enforced the usage of it at Google. Outside of the community, it's not enforced, but very recommended. And it makes that anyone's code looks like yours. So that's very, very nice. It allows you to read very fast. Also, the fact that interfaces are satisfied implicitly is something that at the beginning I couldn't grasp the power of this concept, but actually it means that you can have something very similar to doc typing in a statical language, and it's checked at compile time. And this is actually very powerful. It allows you to break a lot of dependencies between packages that otherwise should be depending on each other. So this is actually something that I really, really like of the language. And finally, concurrency. Concurrency is it's all around the language. And the good thing about it is that it's so easy to use it that you don't actually have to think, oh, should I use concurrency here? Does it make sense? By default, if the process that you're describing is a process that it's supposed to be concurrent, express it concurrently. Then if you're only running on one thread, that's okay. That will totally work. The Go runtime will manage Go routines and just make it work in a single Go routine. So instead of a parallelism, you will have just concurrency. But the good thing is that your code is very simple, and you avoid having, as I was saying before, callback nightmares.
Mm-hmm.
I've been working on the new version of the Go Tour, and I've been doing a lot of JavaScript lately, and that's making me fall in love more with Go.
Yes, exactly. I recognize that from JavaScript. Boy, I don't want to open up a can of worms here, but Dart was just released. How would you have any contrast between Go and Dart if people are trying to choose a language for server-side operations?
So I really like Dart. Last time I got the chance to use it, luckily it was before they released their first stable release. Mm-hmm. So if I didn't use Dart for this new project was because when I started it was not stable. I was not sure about it.
Sure.
Now I think it's a very interesting language, and I really like it for everything that is front end. For the back end, I'm a statically typed kind of guy. I really like if some field is I write my field with some typing error. Instead of writing name, I write name with an N. I want that to be checked by the compiler, not by the runtime. So Dart doesn't really provide that as far as I know. But for everything that I could otherwise use JavaScript, I think that Dart is a very, very interesting option. Yeah.
Very cool. Actually, Dart is strongly typed if you enable the checked operation and you're running inside the Dartium compiler or the Dartium implementation.
Okay.
So yes.
Okay, that's great. When I used it for the first time, it wasn't there. Yeah, it was just optional. So.
Yeah. Well, no, it's still optional, but if you annotate everything in a consistent way, it's going to work.
Okay, you can annotate everything on. Okay, cool.
Yeah. And then even the IDE knows that only these methods can be called on this object, just like you have with any other strongly typed language. So yeah, it'd be pretty close. Cool. Okay, we're almost out of time. We started a little late, which is why most people are probably going, wait, the show's only like 30 minutes in. But no, we started a little late, and we're unfortunately up against hard outs on this show. Is there anything we haven't asked that you want to make sure our audience is aware of before we have to let you go?
So I think that the most important thing, if you're going to remember only one thing of this talk, is that of this podcast, check Go to tour.golang.org. Mm-hmm. And don't get scared about the fact that it's a language that it's object oriented, but there's no classes or implements or extends or any kind of those things. Mm-hmm. It's slightly different paradigm, but it's really powerful when you get used to it. So just go with it for some days, and you'll see.
Very good. That's a really great summarization. I have to ask two other questions or people will yell at me in email. So what's your favorite scripting language?
My favorite scripting language? That's a difficult question. Well, is SED, SED, a scripting language? Not really. I mean, I've used Perl for
well, there we go.
Processing.
You can just stop. Just stop there. That's fine.
Yeah.
You can just stop there. And your favorite text editor?
My favorite text editor is Text Sublime too.
Okay, yeah, well, that's fine. I understand. You talked about Sublime a few times ago. Okay, great. Well, Francesca Campoy, thank you for coming and talking about Go. I know a lot of people have really been wanting to hear more about this. And you just had a recent release. Are we having more releases in the future? Or, well, obviously we are. What do you think the next release is going to be? How long?
So yeah, the next release, it's Go 1.3. And we have the code freeze. So for feature freeze, gonna be in March. So March 1st, very soon. And basically what it's gonna be, we're gonna work on improving the whole runtime. So channels are gonna be faster, arrays and slices are gonna be faster. Also the garbage collector is gonna be 100% precise. Finally, and also we are modifying so far Go routines had split stacks, and actually that was a little bit of a performance problem at some point. So we decided to go with contiguous stacks now, and we implemented it, and it's going to be part of the next version. So it will allow to have even more Go routines with less memory. And actually, there's a huge list of things that are accessible. There's a talk by Andrew Duran. He gave a talk during FOSDEM 2 weeks ago, something like that. And I think there should be already online. So just you should check that. It's a really interesting talk. Just a lot of different things.
Very good, very good. Well, I'm sorry I have to let you go because I have we even got more questions coming from the chat room. But anyway, Francesc Campoy, thank you for coming and talking to us about Go.
Thank you very much for inviting me.
Very good, very good. That was Francesc Campoy, who joined the Go team in 2012 as a developer programs engineer, and he's done a lot of stuff with it since then. So what do you think, Dan?
Yeah, really fascinating. And as you said, I think we could have gone on a lot longer talking to Francesc. So maybe we'll be able to do that again some other time. Really fascinating stuff. I mean, I do. It does look like an interesting language. I'm yet to be convinced why I need to jump into it. But maybe that's just my use cases. I don't know.
Well, and obviously what they found was that this is sort of. It seems like a language that was reacting to just how crazy C++ is to use as a systems implementation language. And also to the fact that C++ has really horrible concurrency things. So it sounds like they took the best of both worlds, inventing a simpler language again, inventing one that's easy to compile, quick to compile, and also having the modern buzzwords, which is concurrency, threading, and things like that. So I didn't get mentioned in the show, but apparently it's a share everything concurrency, although they have some tools that they call like mailboxes or whatever it was, queues, whatever, I forget the name, but so you basically don't have to even worry about that. You basically just send stuff to a port, and then the receiver picks it up from the port, and the threads block until the ports are available, that sort of thing. So it looked pretty good. Like I said, I didn't have a lot of time to play through with it. I will probably not spend a lot of time working on that. Any spare moments I've got right now, I'm working on Dart, so which has a lot of the similar features, I guess, to this, except it doesn't compile down to a single binary like this does. Anyway, yeah, like I said, we could have gone on a lot longer. Unfortunately, if you're watching the show live, you know that we had to start a little late, and I'm going to have to wrap up real quick. Speaking of wrapping up, coming up next week, we have Hydra, which is a distributed data processing and storage system. Think of something like Hive, but can be used all the way down to something like CSV files and all the way up to having thousands of machines do real-time data analysis and deliver the result across multiple receivers. Following that, Monogame, which is an implementation of Microsoft XNA architecture that allows you to write a game once, I guess, to the XNA interface, which is the native Windows interface, or was at least. Somebody told me last week that it was actually canned already. But then run it everywhere. You run it on iOS, you can run it on Android, you can run it on Mac desktops, all sorts of things. So cool, we got to talk to them. Typo 3, for the people who missed our series of CMS episodes last year, we have brought back another enterprise CMS called Typo 3, apparently big in use in Europe. GNU Health after that, which is a top-to-bottom patient management system, health side, billing side, everything you need to run a hospital. CoreOS, which is Linux for massive server deployments. In the short list, we actually have Open Blue Dragon. They're just looking for a date. That's a remote training facility. So basically shared classrooms, remote classrooms, and all the things related around that, like chat rooms and boards, things like that. So it's going to be pretty fun. We have a bunch more on the short list as well. There's a spreadsheet linked from twit.tv/floss that talks about all the people we have on the short list who we're inviting on the show. If you have a project that isn't on that list, please email the project leader. Have them email me, merlin@stonehenge.com, and we'll get them on as quickly as we can. We've got a bunch of slots open in Q2 now, so I'm starting to fill Q2. We do have a live chat room at live.twit.tv. We normally tape at 8:30 a.m. Pacific times on Wednesdays, and so these people got up early, as our guest said, and are basically been in the chat room. Actually, some are in Europe, so it's not early for them, but who cares? Follow us at Floss Weekly at Google+. I announce the new guests as they get added. I also announce just before the show to let you know what we've got coming on. And you can also follow me at Merlin, M-E-R-L-Y-N. But more likely, you'll see more things I'm posting at Google+. That's Randall L. Schwartz, middle initial L. Go check that out. I post probably 4 or 5 postings a day to Google+, to my now 24,000 or so followers. I am going to be at Scale, Southern California Linux Expo, starting only 2 days from now. So if you happen to be in the Southern California area, watch for my tweets and everything to see precisely where I'm at. If I'm actually in the lobby bar, you can drop by and say hello. I'll definitely be there most evenings in the what we call the bar track, which is like the hallway track, but there's more drinking going on. I'm also covering it for FLOSS Weekly, so I'll probably be getting some interviews there. I'm also speaking about my Half-Life with Perl, the talk I gave at OSCON last year that was well received, and doing it once again. That's all I'm plugging today. Dan, what are you plugging today?
Well, I mean, I'd like to mention the fact that Linux Outlaws, which is a weekly show that I do with my German co-host, is back after 6 weeks away. We had a bit of a break while he was off on some secret Black Ops mission or something. I don't know. So he's back now, and you can find us all over the place. Just do a search for Linux Outlaws. We talk about, obviously, Linux, but not just Linux. We talk about all things open source and free software and all kinds of other random stuff as well. So have a look for that. And if you want to find myself, go to danlynch.org. Lynch is L-Y-N-C-H, and you can find Twitter and Facebook and all those things on there. Come and say hello.
But Dan's with 2 N's, right? No, just kidding. Just kidding.
Don't. There is another Dan in the Linux podcasting space with 2 N's.
Oh, really? Well, okay. You're the one with 1 N. You're the one with 1 N, and I'm the Randall with 1 L. Yeah, I'm the Randall with 1 L, which is a little strange, which is funny because my Google Plus ID now, of course, is Randall L. Schwartz, all one word. And so it's Randall with 2 L's and Schwartz, but that's not how you really spell my first name. But oh well, that's just the way it slid out. Well, we're almost out of time. Like I said, we started a little late, so we have to wrap this a little late. Sorry for the slight shortness of the show. We'll hope to do a full-length show next week and every week following that, because that's what we do. We'll see you all again next week on FLOSS Weekly.